clean energy.
Harvesting energy from the sea. Japanese researchers have come up with special technology that can not only capture energy from waves, but also help protect coastlines. A team from Okinawa plans to set up energy harvesting turbines near tetrapods, which are concrete structures placed along the shore to weaken the force of incoming waves and prevent erosion. The turbine has 5 flexible blades modeled after dolphin fins. It's supported by a stem that's anchored to the seafloor with mooring cables, which, like the blades, is flexible and can bend under pressure. Inside the turbine head is a magnet electric generator, which transforms wave energy into electricity. The electricity is sent back to the shore via cables to feed into the grid. Using turbines on just 1% of Japan's coastline can generate roughly 10 gigawatts of energy, equivalent to about 10 nuclear power plants. Apart from tetrapods, the turbines can also harness electricity near coral reefs. They're built to be safe for marine life, with blade speed carefully calibrated so that any animals caught in them can escape unharmed. The team is currently preparing to install 2 half-scale model turbines that will power LEDs as part of a commercial demonstration. MIT says nuclear fusion is only 15 years away. Nuclear fusion could just be around the corner. Researchers at the Massachusetts Institute of Technology, working with a newly formed private company, say they will build a working fusion power plant in 15 years, thanks to a new superconducting material that recently became commercially available. The material is a new superconducting steel tape coated with a yttrium barium copper oxide. The team, working with MIT spin-off Commonwealth Fusion Systems, plans to use the tape to make smaller, more powerful magnets that can be used in fusion reactors. The new magnets will double the magnetic field of a fusion reactor, which means more power can be produced with a smaller device. The smaller size will reduce costs and complexity, making future fusion power plants easier to construct. Limitless clean energy, but what about beautiful clean coal?
Cameroon turns human waste into clean power. 2 towns in Cameroon are installing biogas systems to turn human waste into sustainable energy that can provide fuel and electricity for local communities. Organic material such as animal waste is placed inside an airtight tank where bacteria and archaea break down the material. This releases biogas, which is a byproduct that is a mixture of mostly methane with some carbon dioxide. The biogas can be stored and burned as a fuel for cooking and to power electricity generators, while the rest of the waste can be used as fertilizer. The biogas system installed in Cameroon connects a septic tank to biodigesters, linked to individual households. Human waste placed in the septic tank is converted into biogas by the biodigesters, and this releases energy into people's homes. More than 3,000 households and local schools in 2 towns have reportedly installed the biogas system. It is estimated that the project may reduce greenhouse gas emissions in the vicinity by up to 60%. The project was initiated by Bioenergy Cameroon, a non-governmental youth organization. The group trains local students, especially female students, on how innovative technology like solar power and biogas work. Los Angeles breaks ground on biogas-fueled power plant. A biogas-fueled cogeneration power plant will soon supply enough energy to power a Los Angeles water reclamation facility. Biogas is gas formed by bacteria and archaea that feed off carbohydrates and fats and produce methane and carbon dioxide as metabolic waste. Biogas can be stored as a source of energy, while the remaining waste can be treated and used as a fertilizer. A cogeneration power plant produces steam, heat, and electricity simultaneously. It is more efficient than other kinds of power plants and boilers. The plants can achieve up to 90% energy efficiency, whereas conventional power plants often achieve just 33%, as most of the heat energy is wasted. The 25-megawatt plant is expected to generate more than 173 million kilowatt-hours of electricity a year, and up to 70,000 pounds per hour of steam. That's all the energy needed to power Los Angeles' Hyperion water reclamation plant. Using biogas as a power source is also expected to prevent the release of about 100,000 metric tons of carbon dioxide a year, equal to the emissions from around 21,000 cars. The Hyperion Water Reclamation Plant is Los Angeles' oldest and largest water treatment plant. It has been operating since 1894.
New York is going clean. January 25th was a big day for clean energy in New York after the Long Island Power Authority approved a contract for what's set to be the largest offshore wind farm in the U.S. Deepwater Wind is building a 90-megawatt wind farm near Long Island's South Fork Peninsula. The $740 million project will have as many as 15 turbines capable of powering up to 50,000 homes. The turbines, each about 600 feet tall, will be connected via an undersea cable to a substation in East Hampton. Construction could begin by 2019, with the wind farm completed and operational by as early as 2022. The project is part of New York Governor Andrew Cuomo's vision to source 50% of the state's electricity from renewables within 13 years.
Endless energy with one coat of paint. Researchers from the Royal Melbourne Institute of Technology have invented a novel new paint that can turn surfaces into a hydrogen power generator. Synthetic molybdenum sulfide is a newly developed compound that absorbs moisture and accelerates the splitting of water molecules. When mixed with titanium oxide in paint, the resulting substance is able to produce hydrogen energy from sunlight and water vapor. Hydrogen is one of the cleanest sources of energy and can be used to power vehicles and equipment. The solar paint can generate hydrogen energy in remote locations or hot and dry climates, so long as there is sunlight and moisture in the air. Researchers believe it will take at least 5 years to come up with the final product, but they're confident that it will be cheap and accessible. This solar panel runs on bacteria power. Researchers at Binghamton University have come up with an interesting way to harness energy using a resource we have far too much of: bacteria. To harness power from bacteria, scientists arranged 9 biosolar cells in a 3x3 pattern to form a scalable and stackable panel. The cells use cyanobacteria, which can be found in aquatic and terrestrial habitats, as a source of clean and sustainable energy. In the daytime, oxygen and electrons are released through photosynthetic reactions. At night, electrons are produced from the bacteria's respiratory activities. 5.59 microwatts were generated in 12-hour day-to-night cycles over a total of 60 hours. Solar panels produce about 200 watts in a 6x10 configuration. The biosolar cells in the same pattern will only generate 3.726 100,000th watts. Though not the most efficient, the technology has the potential to be a more reliable energy source. Once the panel is functional, it could power small wireless systems in remote areas where frequent battery changes are impractical. The Binghamton team's work has been published in the journal Sensors and Actuators B Chemical. Dubai greenlights world's largest solar power plant. The world's largest concentrated solar power plant is about to get even more juice. The Dubai government has given the green light to a 700-megawatt addition to the Mohammed bin Rashid Al Maktoum Solar Park. It currently has 2.3 million photovoltaic solar panels with a 200-megawatt capacity. Capacity is expected to grow to 5,000 megawatts by 2030. Developers say the park will eventually cover 214 square kilometers, with a 260-meter solar tower taking center stage. The solar plant produces power by using lenses and reflectors to concentrate sunlight in order to heat fluids, which then in turn produce steam to drive a turbine. The advantage of this type of solar system is that it's more flexible because energy can be stored as heat and used as needed. A drawback is that they are more expensive than photovoltaic solar plants.
Floating Atlantic wind farm could meet the world's energy needs. Would you believe it if we told you the entire world could be powered by a wind farm in the Atlantic? We're not blowing hot air here. According to a new study, building a deep-sea wind farm the size of India that stretches across the North Atlantic could meet the whole world's power needs. Land-based wind farms can produce around 1.5 watts per square meter, while a wind farm in the Atlantic would be able to generate 6 watts per square meter. Several engineering challenges would have to be overcome. A deep-sea wind farm would have to operate in remote and harsh conditions, where waves frequently exceed 3 meters. Laying transmission cables that stretch across the ocean floor, then connect to floating turbines in open ocean, would be another obstacle. A project that big would also require international cooperation and a whole lot of money. Good thing we all get along so well.
Scientists at Lawrence Livermore National Laboratory's National Ignition Facility in California have announced a breakthrough in the development of nuclear fusion, promising an inexhaustible supply of energy. The fusion process uses a fuel capsule placed inside a tiny gold case called a horalm, which is bombarded by 192 laser beams. The temperature inside the horalm is lowered to more than 400 degrees below 0 Fahrenheit to facilitate the fusion reaction. The fuel capsule contained 2 hydrogen isotopes, deuterium and tritium. After laser beams were released, the gold wall of the horalm converts them into X-rays. At high temperatures, the nuclei of the deuterium and tritium are fused together and alpha particles are produced, generating energy. The milestone that the scientists achieved is known as ignition, where the energy produced was greater than the amount of energy put in.
Bionic leaf turns solar energy into liquid fuel. US scientists have developed a bionic leaf that can convert solar energy into liquid fuel. Scientists used a bionic leaf that mimics the chemical processes in photosynthesis to split water into hydrogen and oxygen. A bacteria called Ralstonia eutropha then converts the hydrogen gas into protons and electrons. They are then integrated into carbon dioxide molecules as part of the reproductive cycle of the bacteria to form the liquid fuel isopropanol. Although isopropanol is a combustible liquid fuel, it is currently mostly used as a household disinfectant and as an industrial drying agent to remove water from fuels.